Okay, so before I do some of these problems, I'm not going to do all of them. I want you to see I go through these basic steps, and as long as I maintain this order, I'll get the right answer. Technically, I can do some or more efficient to do first versus the other, but honestly, this is just what's best for me. So the first thing I like to do is get rid of fractions because that's what I think is intimidating. Then I do parentheses. Then I combine like terms, which means things that are on the same side. So if I have 3x plus 5x equals a number, those are on the same side. Okay? Then I get variables on the same side. That's where if I have 3x equals 5x plus a number. Where if I need to get them on the same side, I take this guy and I move it over there. Then I add or subtract by doing the opposite, and I multiply or divide by doing the opposite. I'm not going to do all these problems. You have the answers at the bottom. But there are some problems I think it's important to do. And I think the first one is number 6. So if you remember, first thing I like to do is get rid of the fraction. Well, literally, it wouldn't be a fraction if that 6 wasn't there. It would just be a 5. So what am I going to do? Get rid of the 6 first. Since it's being divided by 6, the opposite is multiply by 6. And when I multiply by 6, it's gone. I'm left with 5t equals 42. Last step to do is divide. I don't get a whole number. I will survive. You can change it to a mixed number if you want, which is 8 2/5, but I don't really care. Okay? Let's do number 9. Now, number 9 feels like I should get rid of the fractions first, but this is one where, honestly, I feel like moving the 5 first is easier for me. So I'm going to minus 5. Because based on the steps, I don't even see the fraction until I get to this step anyways, so it's fine. Now is when the fraction scares me. What makes it a fraction? The 5. What's the 5 doing? Divide. The opposite is multiply. Gone, gone. 15 equals 3x. Divide by 3. X equals 5. Okay? Another problem I think I want to do now is number 11. What makes number 11 difficult is if I'm going to go minus 1/3, now that's uncomfortable. So what I'm going to do is this is where I'm going to get rid of the fractions first. Okay? So what I'm going to do is what makes it a fraction? The 3. What's the 3 doing? Dividing. How do I get rid of it? Multiply it. But the problem is this is a group, this is a group, and this is a group. And I have to give the same thing to each group, just as if I passed out papers to each of you. 3 times 2 is 6. 5 times 3 is 15. Boom, the 3 is gone. I'm left with plus 1. Now the problem, minus 1 minus 1. 7 equals 15x. Divide by 15. X equals 7/15. Okay? Let me move this back a little bit. Let's do number 12. Number 12. I feel like what makes it difficult is they all have a 7. So guess what I'm going to do? I can't just go like this. I'm going to multiply by 7. By, and it ends up working out where I get 2 minus x equals negative 5. This is a common mistake you guys make because you want to add 2, but the minus is with the x. This is a positive 2. If I read this, it says 2. So the opposite of positive 2 is negative 2. And that's really negative 1x equals negative 7, which I might have put the 1 right in the beginning. Negative 1, x equals 7. Okay? All right, let's go to number 13. Number 13, there's parentheses. If you look, the first thing I said to do was multiply. Get rid of the parentheses. And now dot, 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 add 18. Divide by 2, 15. But I want to show you I actually wouldn't have done that. This is where you don't have to go the same path everybody else does. This whole thing is considered one group. So I can take this whole thing and divide it by 2. Which means I'll take this whole thing and divide it by 2. Then I'm left with x minus 6 equals 9. Add 9, I still get my 15. Okay? Now what I want to show you, though, is if you have a problem like this one, let's say you didn't even have that. If I divide by 6, I would have to divide by 6 here and divide by 6 here, which is ridiculous. So it's better in this case to multiply. So keep that in mind. Let me say it again. If I had this same problem where it was 2x minus 6 plus 4 equals 18. So it's the same thing as this problem over here, but I added 4. I can't just go divide by 2, divide by 2. I'd have to divide that by 2 also. Now, granted, it works this time. And then you just put those together and go from there. Now, I would like to emphasize, I didn't divide the 2 from the 6, because this is one group, one division. Okay? Put the same together. X equals 3. Put the same together. Dot, 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 x equals 5. Same thing, put the same together, put the same together. The mistake that you might make, though, you have to be careful. It's 3x minus 4x, and 5 plus 1. Okay. Another mistake people like to make is they go negative 7h and they go plus 14. Don't make those silly mistakes. Put the same together. Add 14, divide by negative 5, negative 12. Okay? Number 18. It's not multiplying by 6. It's multiplying by negative 6. So 7x minus 12 minus 6x minus 3 equals 5. After I multiply, I combine like terms. Put the same together. Add 5, divide by 1, 20. Okay? In this case, we have x's or a's on both sides. I like giving the small to the big, minus 2a. And that's not combining like terms, because combining like terms is when they're on the same side, so you just put it together. This is getting variables on the same side, so you have to move this by doing the opposite. Be careful of that. I get 3a minus 18 equals 3. Add 18, divide by 3, a equals 7. Now, if I go divide by 6 and I go divide by 6, the 7 even doesn't, that's just a mess. So in this case, I'd multiply, 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 and I'd get 6x plus 12 equals 7x minus 21. Just like I like to do the small a to the big A, so I get a positive answer, I want to do the small x to the big X. So I'm going to move this guy over here. Minus 6x. 12 equals 1x minus 21. Add 21, divide by 1, x equals 33. Okay? Last one is a little bit different, so I want you to see. When I multiply this, I don't think that's the weird part. But the weird part is, if I add 3x, I don't even have any x's anymore, which means I can't find the value of x. So if I can't find it, there is not a solution. Okay? But I would like to point something out. Let's say you got the same problem, and instead of saying negative 3x minus 9 equals negative 3x plus 1, it says negative 3x minus 9. So you would add 3x, and you get negative 9 equals negative 9. Well, the x is gone, so it feels like no solution. But the problem is, this side is equal to this side, exactly equal. Why, negative 9 is equal to negative 9. How often is that true? All the time. But you don't say all the time. You say infinite solutions. That means no matter what you put in here, you'll put in here, and this side will always be equal.